Hi everyone, welcome to Job Fever. Hi everyone, welcome to Job Fever. So today we are going to start new series of list. We are going to understand complete implementation of list interface. So list is the interface which is introduced in Java collections framework. Okay, so these all are the implementation of list. Implementation class of list. So we are going to see one by one in this tutorial. So firstly we'll discuss about the vector, what is vector, and the coding questions of vector from core to advanced. So vector is a implementation class of list interface. Stack is also a implementation class of list interface. So we are going to see all the questions from basics to advanced in this upcoming tutorial. Okay, upcoming slides. And next we'll see array list. Okay, this is also implementation of list interface. And after that we'll see linked list. So linked list is also implementation of list interface. So we are going to see all the classes which implement list interface in this upcoming slides. Okay, so we are going to cover all four classes, and we'll do the coding also to understand. We'll see all the methods. Okay, difference between array list and linked list, what is a stack, what is vector, internals of vector, a stack, okay, how it internally works. Okay, so we are going to complete scenario, all the method which is available in all these classes. Okay, and we'll do the coding questions. So let's get started. We'll discuss what is vector. Okay, we are going to cover in this tutorial syntax of vector, how can we declare the vector, okay, how can we create vector, and advantage of using vector, disadvantage of using vector, and constructors in vector, methods using vector, and difference between vector and array list. So it is a very important question according to interview. And coding questions of vector, we are going to see coding questions of vectors. Okay, so let's get started. So firstly we are going to touch what is vector. Okay, so in Java, the vector class is part of the collections framework and implements the list interface. Okay, so you know the hierarchy of collections framework. Okay, so in collections framework hierarchy, if you'll see, so you'll get the list, you'll get the set, you'll get the map. Okay, so in list interface, okay, so vector is one of the implementation of list interface. Okay, which allows it to hold a dynamic array of elements. So we can store dynamically with the help of the vector. It is similar to an array list, but there are some key differences mainly related to its synchronization and performance. So it is similar to array list. So in array list also we can store multiple objects. Okay, so in vector also we can store multiple objects. So but there is some difference between vector and array list. Okay, which is related to synchronization and performance issue. So so this is the hierarchy of vector. Okay, in collections framework. So iterable will be the interface, main interface, and then collection is also interface. So collection extends iterable, and list is also interface which extend collection. Okay, and vector implements list, and stack implements vector. Stack is a class. Stack also extends vector. Okay, so stack is also a data, uh, also a type of data structure to store objects. Okay, so we are going to concentrate on vector. Okay, so this is the hierarchy of vector in collections framework. We are going to describe vector. Okay, so vector implements a dynamic array, which means it can grow or shrink as required, like an array. Okay, so in it implements dynamic array. Its content component that can be accessed using an integer index. So you can so it store with index. Okay, so we can store at index wise, and we can get by index, we can read by index. Okay, so it's internally follow a dynamic array, a growable array, you can say like this. They are very similar to ArrayList, but vector is synchronized and has some legacy method that is the collection framework does not contain. Okay, so there is some legacy method inside vector, but in ArrayList there is no any legacy method. ArrayList is introduced in Java 1.2. Okay, but this vector is introduced in Java 1.0. Okay, uh, at the time of starting only they introduced vector. Okay, so there is some legacy method inside vector, but there is no any legacy method inside ArrayList. So this is also a difference. So it also maintains an insertion order like an ArrayList. So ArrayList also maintain insertion order, and vector also maintain insertion order. Still, it is rarely used in non-thread environment as it is synchronized. So if vector is synchronized, so better not to use synchronized method inside multi-threaded environment, because you'll get the incorrect value. You may get the incorrect value if multiple thread will try to fetch that uh, fetch your value. Okay, which is vector. Okay, then in that scenario you may get the incorrect output. So better not to use vector in multi-threaded environment. So always try to use any non-synchronized data structure. Okay, so it gives a poor performance in adding, searching, deleting, and updating its element because it is synchronized. Okay, so performance wise it is also slow because only one thread can access at a time. So and the iterators return by the vector class are fail fast. Okay, so if you use this vector class as a as a iterator, so it will be fail fast. In the case of concurrent modification, it fails the through the concurrent modification exception. So if you use vector also for to at the time of iterating. Okay, if you try to add or modify or delete something, okay, in your vector data structure, then you will get concurrent modification exception. Okay, same like array list. In array list also you will get the concurrent modification exception. So this is the common between array list and vector. In hierarchy of collections, okay, we are going to see hierarchy of collection. So this is the main iterable interface. Okay, collection is a list, iterable is also a list. So iterable collection extend iterable. Okay, and we are concentrating here on list. So list implements collection. Okay, queue also implements collection. Queue sorry, list is a interface, queue is also interface, and set is also interface. Okay, so set extends collections. Okay, because both are interface, so interface extends. Okay, and class implements. So we are concentrating only here on vector. So array list also implements list, linked list also implements list, and vector also implements list, and stack also implements list. Okay, so stack implements vector and vector implements list. Okay, so like this is the scenario. So you can also see the set. Okay, so hash set is there, link hash set is there, queue, dq is there, priority queue is there. Okay, so here we are concentrating on vector. Okay, so it is a complete hierarchy of collection. So what we are doing, you have to understand from basic. Okay, so we are going to see syntax of vector. How can you declare a vector? How can you create a vector object? Okay, so this is the syntax. So if you see the vector class, so you'll get, so vector extends of stack list and implements list, random access, clonable, and serializable. These all are interface: serializable, clonable, okay, list, random access. So vector implements list, random access, clonable, serializable, and vector implements abstract list. So if you see the code of this vector, you will get. Let me show you code of a vector. Okay, it will not take more time. It will be easy to understand. If you see the code, okay, I have already written here. Okay, so this is the vector. If you'll see the code internals of vectors, okay, yeah, so here the see vector is a class. So vector extends of stack list, which is also a class, okay, and vector implements list. In list is interface, random access is interface, clonable is interface. Okay, so if you see the random access, so random access is also a interface. So this is interface. Okay, clonable is interface, you know very well, and serializable list, you know also. Okay, so this is the internals of vector class. So let's continue our topic. So it's extend abstract list and implements list interfaces. Just now we seen. Okay, so it's implements serializable, clonable, iterable, collection, list, random access interfaces. Okay, so it's implements serializable, clonable, iterable. Okay, so because if you see the list, okay, so list also, list implements collection. Okay, and collection implements iterable. Okay, so indirectly vector implements serializable, clonable, iterable, collection, list, okay, and random access interfaces. So this is the basic things of vector. So you need to understand everything from code to advanced. The directly known subclass is stack. Okay, so stack is a subclass of vector. Okay, because stack extends vector. Okay, so this is the known subclass of vector. Now we are going to see advantage of using vector. Okay, so synchronization, as mentioned before, vector is a synchronized, making it safe to use in a multi-threaded environment. Okay, so if you want to use inside multi-threaded environment, then you can use vector. We have an option. So this is also advantage of vector. If you see in advantage wise, okay, and dynamic size, the size of vector can grow or shrink dynamically as elements are added or removed. So we can also increase the size dynamically. Okay, because in array we can't increase the size dynamically. We have to provide the size of array at the time of declaration only. But in case of vector, okay, it will grow dynamically. It will be, your size will be added dynamically. You can add and remove. So you don't have to worry about setting an initial size. That will accommodate all elements. Okay, so no need to provide the size at the time of declaring the vector. Okay, so without size also vector object will be created, and once it will be fulfilled, okay, then by its threshold, then it will be, size will be increased. So dynamic size, this is also advantage. And legacy support, so vector has been part of java since its inception and is still supported. So it's a good option if you need to work with older java code that uses vector. Okay, so this is a legacy, it support legacy. So if you want to still uh, if you still want to use the legacy things, okay, in legacy project, then it will be good to use. Okay, if you'll see in advantage why, but nowadays no one is using vector. Okay, so this is a disadvantage of using vector. So performance wise, the synchronization in vector can lead the slower performance compared to other collection like such as ArrayList. So this is the slower than ArrayList. Performance wise, it will be very slow because this is synchronized. Legacy wise, so this is the legacy. So nowadays no one is using. Okay, so this is also issue, and unnecessary overhead. Okay, so if you don't need to synchronization features of vector using it, it will add unnecessary overhead to your code. Okay, so this is also issue. So, oh, we are going to see now constructors in vector. So, in how many ways we can create vector? So, this is the first way. Create a default vector of the initial capacity is 10. So, if initial capacity will be 10 for vector, so this is applicable for ArrayList also. If you are creating ArrayList, so initial capacity will be 10, same as vector. Okay, so like this we can create the vector instance. Okay, and this will be the type E. Here we can provide like a string, integer, double. Okay, according to your requirement you can provide. So, yeah, if you are using, so vector size will be 10. Okay, and it will be increased if the threshold will be fulfilled. And second will be like this we can create the vector with size. Create a vector whose initial capacity is specified by size. So if you provide there 10, 20, 30, 40 like this. Okay, so that size will be considered at the time of creation of vector. Okay, so if you are making 20, then uh, 20 one vector will be created with size 20, capacity 20. So this is the size and INCR. Okay, create a vector whose initial capacity is specified by size. We are giving size here also, and increment is specified by INCR. So how it will be in- increased? Okay, how size will be increased? Like this, we can provide size plus how you want to increase the size of vector like this. So it specifies the number of elements to record each time a vector is resized upward. So like this, we can also create with size and INCR. And fourth way, we can also create a vector that contains the elements of vector collections. We can provide here. Okay, like you can provide array list also, and any collection also you can provide at the time of creating vector. So we have four ways to create the vector. Okay, basically most of the time we use this. Okay, first one. So you can choose anyone according to your need, and we are going to see quickly all the method which we use in vector. Okay, so we have add method to add. Okay, append the specified element to the end of this vector. Okay, so it will add the element. Okay, and add by the index, add all we can also do. Okay, so here we can provide the collection, add all with index and collections. Okay, where we want to add element is also this is the legacy method, add element. Okay, capacity is there, so it will return the capacity of your vector. Clear, it will remove all the available object. Clone, so it will provide the clone. Contains, if something is contains, okay, object contains, it will return true and false. Contains all. Okay, copy into, so copy the component of this vector into a specified array. Elements at, okay, so returns the element, it will return the element. So elements returns an enumeration of the component of this vector. Okay, insert capacity, mean capacity, so it will provide this will be the mean capacity. Okay, increase the capacity of this vector if necessary to ensure that it can hold at least the number of components specified a minimum capacity argument. So these are the methods. Okay, so we are going to quickly cover. So, and we'll do the coding also. Okay, to understand the equals method there, equals to compare the objects. Okay, so it is a very famous method. First element, so you'll get the first element. For is to iterate. Okay, to iterate your vector you can use for each. Okay, so for each is available in collections, collection interface. So sorry, collection interface, yes, yes. So because vector implements collection, so we are getting here also for each. Get method, so we can fetch the get by index hash code, to generate the hash code. Index of, okay, so it will return index of your object. Okay, if it is not available, then it will return -1. Okay, so index of object in int index. Okay, so return the index of the first occurrence of the specified element in this vector, searching forward from the index, or returns -1 if the element is not found. So like this insert, you can insert also on which index we want to insert. So you can use this is empty, so you will get the with the help of this you will get the true and false. So iterator, with the help of iterator method we can also iterate. Last element you will get, last index by the object you will get, last index of object and index. So we have to provide the object and index of that one, so you'll get the last index of, so returns the index of the last occurrence of the specified elements in this vector, searching backward from the index, or returns minus one if the, sorry, if the element is not found. So this is the, these are the methods. Okay, remove, to remove the index by, remove by object wise, remove all, to remove all things, all the collections, remove all elements. So remove all component from this vector and set its set size to 0. So remove elements, so here also, so it's a legacy method. Okay, so it will remove by object, so remove element at, so index wise it will also, it will remove if. Okay, so you can provide the predicate. Okay, you can provide your own logic. Remove range from index to index. Okay, from where to where, from where to where you want to remove, you can provide the range. Replace all, it will replace. Retain, okay, retain only the elements in the vector contained in the specified collections. Set, we can also set element and index where you want to set the element. Set element at. Set size, new size you can set, size you can get. Okay, sort, you can sort, like we have a, like in increasing and descending order you can sort like this. So here we are providing the comparator. Splitter also, okay, for it fail fast split over the element in this list. Sublist, okay, returns a view of the portion of the list between from index inclusive and to index inclusive. Okay, so from and to you have to provide, then you will get the sub vector. Okay, vector inside the vector you will get. To array, it will convert into array, returns array containing all the elements. To array, okay, two string is also there, which is very famous, as you know already. Trim to size, okay, so trims the capacity of this vector to the vector current size. Okay, and list iterator is also there, returns list iterator over the elements in this list. Okay, so if you want to iterate, okay, for the list you can use. So these all are the methods inside the vectors. So you can use, you can play with all the methods. Okay, so I discussed quickly, so within 3 to 4 minutes, okay, to understand each and every things. No need to understand each and everything. So if you do the coding, then you can play with these all methods you will get. So we'll cover all this and all necessary methods in our coding section. Okay, because we have so many methods here, almost 40 to 50 methods. So we are going to see difference between vector and array list. So this is the most important questions. Okay, according to interview. So vector and array list, so feature synchronization. Okay, so synchronize, you know, vector is synchronized. Okay, so if synchronized, that means it is thread safe, and non-synchronized, array list is non-synchronized, that means non-thread safe. You can't use this vector, okay, in multi-threaded environment, because it is, sorry, you can't use array list in multi-threaded environment because it is non-synchronized. So better not to use array list inside multi-threaded environment because it is non-synchronized. And vector, which is synchronized, that means it is thread safe, so we can use it inside multi-threaded environment. All methods are synchronized, making it safe for multi-threaded performance. So vector is slower than array list. Okay, and growth policy, so double its size when it need to grow. So it will make the size double when your threshold will be completed. Okay, and arrays increase its size by 50% when it need to grow. So size will be enhanced by 50% in case of array list. So legacy status, so vector is legacy and array list is introduced in Java 1.2. So thread safety, so a vector is thread safe. So vector is thread safe and array list is not thread safe. So iterator, so it is fail fast in case of vector, but it is also fail fast. Okay, so both are similar. So it also throws the concurrent modification exception in case of array list, and in case of vector also it's also throw concurrent modification exception. So both are similar functionalities. and uses used in modern code, so really used in modern code because this is legacy code. So nowadays no one is using vector, and most of the persons are using this array list. Initial capacity, so initial capacity will be 10 for this vector, and for array list also initial capacity will be 10. So this is similar. Okay, so capacity increase, so can specify a capacity increase capacity by this amount when full. Okay, and capacity, if vector will be full, then it will be doubled. Okay, just now we seen the it will make the size double its size when it needs to grow. So when, so default initial size is 10 elements, can be specified at instantiation. Okay, but can specify a capacity increment. Okay, increase capacity by this amount when full. So once it will be full, so the capacity will be doubled in case of vector. Okay, but in case of ArrayList, the size will be increased by 50% of the current size. Okay, when it will be full, so it will be 50%, it will be increased by 50%, but it will be double. So legacy method, so legacy method is available, just now we discussed. Okay, add element is a legacy method. Okay, inside vector, and remove element is also a legacy method inside vector. Okay, but there is no legacy method inside this, inside array list. Okay, in use cases, so use when thread safety is priority, and performance is less critical. So that means we can use in thread environment. Okay, and use in single threaded or non-concurrent application for the better performance. So we can use released inside non-threaded environment. Okay, so if you don't want to perform any concurrent operation, okay, then you can use this array list. Namespace part of Java tutorial package, and both are the part of Java tutorial package. So this is a similar functionality. So there is some difference between vector and array list we discussed, and some similarity is also there. So we have also touched. Okay. So this according to the feature. So now we are going to do coding part to understand clearly. So how it works. Okay, code wise. So let's start coding. So I have already did one POC, so I will show you quickly. Okay, so how it works internally. So this is how we can create the vector. So this is the one of the one of the constructor to option to create the vector. So we are creating vector with no constructor, no argument we are passing. Okay, so one vector will be created with size will be here 10, default size will be 10. So we are going to add some elements. So how? So we have apple, banana, cherry, we are adding vector dot add is a method. Okay, so here we'll get uh, vector, and we'll get the apple, banana, cherry date. Okay, if you want to add, so you will get here after adding, you will get one list. Inside list you will get apple, banana, cherry, date. Okay, so if you want to add with index, so here we can provide index, and here we can, there is a grapes is a string. So we have also provided which type of the data you want to store inside vector. So we have provided a string here, so we are just adding all the strings object inside vector. Okay, so here we can add a grapes at second position. So let's run and check one by one, are we getting the, so I'm going to comment the unnecessary things. Okay, so we'll enable once required. Okay, so it will be easy to understand. So let me comment the, so we will see one by one. I've done one POC to save your time. So let's run one by one and check. So now we are adding only. Okay, so we'll add and we'll check. So if everything, if it will be, so if it will work fine, then we'll disable all comment and we'll check. So now we have commented everything. Okay, now we are going to see only addition part. Are we able to add in vector or not? Okay, so let me run and check. So see here we are getting apple, banana, cherry and date. Apple, banana, cherry and date. Okay, so we are getting correct output. So we have created one vector with the help of no argument constructor. Okay, and we have added, and we are getting apple, banana, cherry, date inside a list. Okay, so now we are going to add at index wise. Okay, so we provide the index where you want to add. Okay, so we want to store at second place, that means the 0 1 2 3. So instead of cherry it should be grapes. Okay, and cherry should be at next position. Okay, so our output will be like apple, banana, grapes, cherry and date. So let me run and check is it working fine or not. So let me run quickly. Yeah, we are getting apple, banana, grapes we are getting here, but that means it's adding at second index. Okay, and then cherry and then date. So like this we can add vector that add with index. And we have third scenario, which is accessing an element at a specific index. So now we are fetching the object which is at first position. Okay, with the help of the get, we are providing here index. So now we'll get here what should our output should our at first person banana is there, so our output should banana. Let's run and check are we getting banana or not. So we are getting banana, so it's working fine. So functionality will be same as array list. Okay, so now we are going to remove banana. So we are going to remove, so we have removed method with object, with index. Okay, with uh, collections. Okay, we remove all, we can remove if, remove element. Okay, these all are methods. So we are going to use here remove with object. Okay, so here object is our banana. So now banana should be removed from this index, and apple, grapes, cherry and date should be our output. So let me run and check are we getting correct output or not. Apple, grapes and cherry and date. Okay, so banana is removed from our list, so we are not getting banana. So this is the correct output we are getting here. So now fifth will be the removing an element by index. So we are going to remove element by index from which, from where you want to delete or remove the element. Okay, so from second position, second index you want to remove. Okay, so we are providing a remove and second index, that means 0 1 2. So cherry will be deleted, so our output should be apple, grapes and date. So let me run and check are we getting correct output or not. So yeah, we are getting apple, grapes and date. Okay, so now cherry is not available because we have removed this cherry with the help of this remove method, and we are providing remove with index. So checking if the vector contains an element. So we have contains method, so it will return true and false. Okay, if so we have vector, okay, which is apple, grapes and date. Okay, so it will check apple is available on this in this vector or not. If it is available it will return true, if it is not available then it will return false. So let me run and check, it should return true because apple is available. So it's returning true because apple is available inside this list. Okay, inside this. So now we are going to see getting the size of the vector. So what is the size of vector? So with the help of the size we can uh, calculate the size of the vector. So current size will be 3 because we have apple, grapes and date. So let me run and check are we getting 3 or not. So now we are getting here 3, that means the our output is correct. So size is also working perfect, and this is the way to get the size of vector. Okay, same like array list, and this is the way by which we can iterate. So we are using the enhanced for loop. We can also use the for each method, we can also use the iterator. So we have 3 to 4 ways to iterate. So we are using here uh, for enhanced for loop to iterate. So here vector, and we are using here string. One by one it will iterate and it will provide the. So let me run and check are we able to iterate with the help of this or not. Yeah, so we are able to iterate with the help of this enhanced for loop. Okay, apple grapes date we are getting, so like this we can iterate and checking vector is empty or not. Okay, so how can we check vector is empty? Okay, so it will return true and false. So what should be output? So vector is not empty, so it should be false. So yeah, we are getting false. Okay, so we are getting the correct. At last we are going to creating all the elements from the vector, so we are going to delete all the elements which is available inside vector, and it should give a empty list, empty. Okay, so let's run and check. Yeah, we are getting the empty list. Okay, so this is the way by which we can add, remove. Okay, we can check the size, we can iterate. Okay, we can add by index, we can add by object. Okay, we can fetch with the get method, we can remove by object, we can remove by index. Okay, so almost 40 to 50 methods are there. So these are the necessary method which we frequently use in our code. Okay, but if you want to play with the methods, okay, which is available inside vector, you can go and we can check and you can play. If there is any doubt, all you can also comment, so we can discuss on open platform. I hope you understood all this topic, which is first we will cover what is a stack, second working of a stack, third a stack in Java collections, constructors in a stack, then we'll cover key methods of a stack, then methods used in a stack, coding questions of a stack. So we are going to cover all these topics in this upcoming tutorial. Okay, so let's get started. So firstly we are going to see what is a stack. So a stack is a linear data structure. So we use a stack to store object. Okay, so a stack is a data structure, a linear data structure. Okay, that follow the LIFO, that means the last in first out concept. So this is the core concept of a stack, which is LIFO, that means last in first out. So your object will be inserted at last, but it will be out at first. Okay, so because of that we call a stack as a LIFO order stack data structure. Okay, so it support LIFO principle. A stack has one end, whereas the queue has two ends. So this is the difference between a stack and queue, you can say. So queue has two ends, front and rear, but a stack has one end which is top. Okay, so it contains only one pointer, top pointer. Okay, so there is only one pointer in a stack, which is top pointer, so pointing to topmost element of the stack. Okay, so wherever an element is added in the stack, it is added on the top of the stack. So if you add any things on a stack, so address of that stack will be stored in the top pointer. Okay, so if you add another thing, another object, another data on top of the stack, uh, f- then top one address will be stored in your top pointer. Okay, so only one pointer will be, top pointer will be there here. Address will be stored. Okay, like xx10 you can say. Okay, address of the top object. Okay, so it is added on the top of the stack, and the element can be deleted only from the stack, only from the top. Okay, so if you want to delete the element, so it will be only deleted from the top only. Okay, so in other words, a stack can be defined as a container in which insertion and deletion can be done from one end, known as top of the stack. So insertion will be also done from top, and deletion will be also done from the top. So this is called a stack. So it happen only in stack. So this is the how we store data in stack. So insertion is called push here in stack, and deletion is called pop. So what is happening here in push? So we have stored a, b and c. So first we have stored a, and then we stored b, and then we stored c. So if you see the top, so we have c here. Okay, so let's imagine our address of c is xx10. So this xx10 will be stored as the top pointer. Okay, where it will be stored? So here, so we have already given here. So this is the address of top. Okay, so if you delete this c, then what will happen? So address of b, which is xx20, will be stored. Where it will be stored? It will be stored at top. So if address is b is xx20, then xx20 will be stored here. Okay, so 10 will be removed and 20 will be stored here. So like this stack works. So here we are removing the c, then b will be on top. So now just now I explained. So now address of b will be stored here in top pointer. So like this stack work. Okay, so this is internals of stack. So working of a stack we are going to see. So a stack works on LIFO pattern. Just now we seen LIFO, that means last in first out. Okay, so if your data will be stored at last, then it will be out first. Okay, this is the pattern. This is the principle, LIFO principle, as we can absorb in the below figure. Okay, so I have already given one figure. Okay, there are 5 memory block in stack, therefore the size of a stack is 5. Okay, so this is the size of a stack. So we have stored 5 elements, so size of a stack is 5. Okay, so we are pushing from 1, then 1, then 2, then again we are pushing 3. Okay, so 1 2 3, then we are pushing 4, 1 2 3 4, then we are pushing 5. So we have 5 object in this stack. Okay, suppose we want to store the element in the stack, and let's assume that stack is empty. We have taken the stack of size 5 as shown below in okay, which are pushing the elements one by one until the stack becomes full. Okay, so like this we can store. Since our stack is full, as the size of a stack is 5, so our stack is full, so size of a stack is 5. In the above case, we can observe that it goes from the top to bottom. Okay, when we were entering the new element in the stack get filled up from bottom to top. So firstly bottom will be filled, then top will be filled. So like this stack works. When you perform the delete operation on the stack, there is only one way to entry and exist, as the other end is closed. So it follows the LIFO pattern, which means the value entered first will be removed last. Okay, so if you want the value which you inserted first, so it will be removed at last. Okay, because it's follow LIFO concept. So you have inserted first. Okay, first you have inserted. Okay, you have inserted one. Okay, uh, then it will be, when it will be removed, so it will be removed at last. Okay, because we have two first, then we have firstly we have to remove 5, then 4, then 3, then 2, then 1. So the data which you are inserting first, it will be removed at last. Okay, in case of LIFO principle. In the above case, the value 5 is entered first, so it will be removed only after deletion of all the other elements. So in the above case, the value 5 is entered first, but in this scenario, we are storing 5. Okay, so this scenario is applicable for the below. Just now we discussed. Okay, for this scenario, but here we are entering first. Okay, so it will be removed at last, and at last we are entering 5, inserting 5. Okay, so it will be deleted at first. Okay, if you want to delete, then firstly we have to delete 5, then 4, then 3, then 2, then first. Okay, so like this it will work. So you can't delete from you can't directly delete one, okay, because you have to only one we have a point to delete or insert, only one open point, okay. So it is closed from this side, okay, and stack is open from one side. So one side closed and one side open, okay. But in case of queue it will be open from both the side. You can delete from both, you can insert from both, okay. So a stack in Java collection. So we are going to see how a stack works in Java collections. So Java collection framework provides a stack class that models and implements a stack data structure. The class is based on basic principles. Just now we see last first out. In addition to basic push and pop operation, the class provides three more functions: empty, search, and so these are the key methods of stack, which is push, pop, empty, search, and peek. Peek, that means that we can fetch the top element. Search, we can search by index. Empty, if it is empty or not, you can check. Push, that means the insert, and pop means delete, okay. So like this, such as push, pop, here all the methods are declared here, key methods, empty and search, okay. The stack can be indeed referred to as a subclass of vector inheriting its method and properties. Okay, so subclass so a stack im- extend the vector. Okay, so vector is also a implementation of list. Okay, so vector implements. So just now we are going to see this. We are going to see this. See, vector is the implementation of list. List is interface, okay. So vector is implementation of list, and stack extend this vector class, okay. So all the method which is available in vector class will be available in stack, because stack extends vector class, okay. And list extends collection interface, and collection extend iterable interface. So this is the hierarchy of stack. So our concentration on stack, okay. So some methods are already, some methods are available, okay, which is not available in vector but only available in stack, which is key methods of stack, that is push, pop, pick, empty, and search. So these methods are available only in a stack class, okay, not available in vector class, okay. But all the method which is available in vector class is also available in stack class, because stack extend vector class, okay. So hierarchy of collection. So this is the complete picture of collection, okay. We have a iterable interface, okay. Collection extend this iterable interface, and then we have list, queue, and set, okay. So before we seen, there is a list. So array list is a class which implements list interface. Linked list is also a class which implements list interface. Vector is also a class which implements list, okay. And stack is also class, stack implements vector, okay. And vector indirectly extends, so implements list interface, okay. So this is a scenario for list, and this will be the scenario for queue, okay. So queue, priority queue, dq, array dq. Set, we have set is interface, has set is there, link has set is there, sorted set, tree set, okay. So but now we are concentrating on only stack. So I shown you this picture, okay, to be complete for complete understanding. So now we're going to move key methods of a stack. Just now we discussed empty, pick, pop, push, and search. These are the key methods of stack. Okay, so empty, that means it returns true if nothing is on top of the stack. Okay, that means that it is, if it return true, that means that it is empty. Pick, that means it will return the top of the stack. Return the element top of the stack which is available. Okay, but it will not remove, it will not delete. And pop, that means that it will delete the top, remove and return the top element of the stack, okay. So it will remove the top element which is available on top of the stack, and it will return, okay. So an empty stack exception, and exception is throw if we call pop, and when the invoking stack is empty, okay. If stack is empty and if we try to call stack.pop, then in that scenario you will get empty stack exception. So and push, that means the to insert the object, to insert the data we can use push. Okay, search, we can search by element wise. Okay, if element is not available, then it will return -1, otherwise it will return that element. Okay, so like this. So constructors in vector. Okay, so constructors stack creates an empty stack with an initial capacity 10. So initial capacity will be 10, same as array list and vector. So initial capacity will be also same for stack also. So like this we can create new stack. Okay, and this will be the type, which type of the stack you want to create, like integer, string, long, double. Okay, so this is a type. So one stack will be created with capacity 10, and it follow and it will follow LIFO order vector. Okay, so second way is also there to create. So like this we can also create a stack. Inside we can pass the capacity 20. Okay, like this we can do, but internally it is vector. Okay, vector constructors. Okay, see, create a stack via vector with the specific initial capacity. Okay, create a stack with initial capacity 20. So it will internally use the vector to create this stack with given capacity. So there is also third way to create. Okay, like this we can also create. This is the capacity and this is the increment size. So if it will be you full, then it will 5 capacity will be added. Okay, so initial capacity will be 20 and increments by 5. Okay, so we are given when 20 will be completed, then your size will become 25. So like this we can also creates a stack via vector with a specified initial capacity and capacity increments, which determines how much the stack will grow when it need to expand. Okay, so like this we can also create. So this is the third way to create, and now we are going to see fourth way. Okay, so we can provide the collection. So list, this is the collection, this is the constructor. Okay, so this is we are doing creating the stack. This is the constructor with list parameter. So you can provide any collections. Okay, this is the parameter we are getting collection. So now we are providing the list parameter. So one stack will be created with list parameter. So like this we can create a stack. Okay, so now we are going to see key methods of stack. We have already seen. Okay, so we will skip. So now we are going to see method which is available in vector. Okay, but because we extend the vector class, so all the methods are also available in stack class. Okay, so we can also use these methods because these all methods are available in vector class. So I have already explained all these method in previous video. Okay, so please go and check uh, the vector tutorial. You will get the concept of all these methods. Okay, so these are all the known methods. Okay, it will not this all methods are there. Okay, capacity, clear, clone, contains all. Okay, these are the methods which is in vector class. So you can see one by one. Okay, equals first element for each get has code index. Okay, is empty, you can iterate with the iterate last index. Okay, remove. Okay, you can remove by object, you can move by index. Okay, retain, remove, set, size, sort, all the messages, splitter, sublist, to array. Okay, to string, trim to size, list iterator, list iterator by index. So all these methods are available in vector class. So please go to my previous video and see. I have explained all the methods. I'm not explaining all these things here because it will take too much time. Okay, so now we are going to see coding questions of stack. So how it works. So let me show you. I have already did one POC. So I will see how stack works. Okay, so I have created one class. Okay, which is, so I'm going to remove firstly we'll check how we can insert data in with the help of stack, and then we'll see pop. So we are going to see all the necessary method. Okay, I'm going to comment all these things. Okay, we'll try to understand one by one, otherwise it will be difficult to understand. Okay, so now I have I'm going to comment. So yeah, I have commented. Now we'll check one by one. It is from. So like this we can create the stack. This is the constructor without parameter, so it will create in a stack with size 10, capacity 10. So now we are going to add here pushing element on the stack. So like this we can do with the push method. We can insert data inside a stack. So stack dot push we are inserting 10, stack dot push we are inserting 20, stack dot push 30. So how it will be inserted? Okay, so 10 will be at uh, at bottom, okay, and then 20 and then 30. So like this. So 10 will be first, 10 will be at bottom position, then 20 and then 30. So like this. So if we try to remove, so it will be move from top. So on top we have 30, okay. So like this it will be. So let me run this. We should get 10, 20 and 30. So here we are getting 10, 20 and 30. Now we are going to pop, that means the to delete. So from where it will be deleted, because it is a stack, so it will be deleted from top. So what is there on top? So first we have inserted 10, then 20, then 30. So 30 is inserted at last. So on top 30 is available. So if you try to pop, then 30 will be deleted. So our output should be 10, 20, because we are trying to delete. We are doing pop here. So stack dot pop, that means the popped element will be 30, because 30 is on top position, because we are inserting at last. So here we will get 30. Let me yeah, 30, it should get 30. So popped element will be 30, and our remaining stack will be 10 and 20. So let me run and check, are we getting correct output or not. Yeah, popped element is 30, because 30 is on top, and now we are remaining item we are getting 10 and 20, okay. So like this pop will work. Now we have peak, that means the we can fetch top of the element, okay. The element will not be deleted, it will only fetch the top of the element. So stack dot peak. So what should be our output? What is on top? So we have already removed the 30, okay. So what is on top? So on top 20 is there, okay. So if you try to fetch with the help of the stack dot pick, it should be we should get 20 here, okay. So let me run and check, are we getting correct one or not. Yeah, we are getting top element using peak, which is 20, okay, because we have already removed 30. So we have only 10 and 20, and 20 is on top. So checking if a stack is empty or not. So with the help of this empty method we can check stack is empty or not. So we have two elements in a stack, so it is not empty, so it should return false. So here it should false. Let me run and check, are we getting false or not. So here we should get a false. Yeah, here we are getting false, so it's working according to our expectation, okay. That means we are able to analyze correct output, okay. So it's working fine. Now we are going to see searching. We are going to search with the help of search method, stack dot search. We are going to search 20. 20 is available or not, we are going to search. Sorry. So if position is -1, if position is not -1, that means the 20 is available, okay. So it will provide the position. So where is the 20? So if position is not -1, that means the 20 is available. If position is -1, that means the 20 is not available, okay. So Let me run and check. We have 10 and 20, so 20 is available here, so it should print what it should print. Element 20, element 20 is at position, so it should print position. So because we have 20, so we are getting element 20 is at position first. Okay, so we are getting this element 20 is at position first. Okay, because at 0th position what will be there, 10 will be there, and at first what will be there, 20 will be there. So we are getting correct output according to our expectation. So now we are going to s- print the size. So how can we print the size of stack with the help of the stack dot size? So our output should be 2 because we have 10 and 20 in our stack. So let me run and check. It should give 2. We are getting size 2, so it's working correct. So now we have clear method, okay, to clear the stack. So we are doing a stack dot clear, and we are printing a stack, and then stack dot empty we are checking. So let me run and check what we are getting. So we'll get empty here, and stack dot empty, that means we will get here is empty, that means we will get here true. So here we are getting the empty stack because we have already did clear, that means that nothing is there inside, all element will be deleted, and we are checking stack is empty or not. So we are getting here true. So like this, all the key elements, all the methods are working in a stack. So I hope you understood all the points. If there is any doubt, so please comment. All these topics in this tutorial, which is what is array list, important features of array list, constructors in array list, methods in array list, and coding questions of array list. So we'll touch one by one. We'll try to understand what is array list. So Java, so array list is a part of Java collection framework, and it is a class of java.util.package. Okay, it provides us with dynamic array in Java. Okay, so it's a part of collection framework. Okay, so it is available in java.util.package. It may be slower than standard array, but can be helpful in the programs where lots of manipulation in array is needed. So in array we can store similar type of data. Okay, but in array list we can also store. So there is some advantage to use array list, which is growable array. Okay, so if you are going to add multiple more than or defined size, then you can add with the help of array list. Okay, so in array list if you want to add any data, we have to firstly define the size of the array list at the time of declaration only. But in array list the default size will be 10, and it will be growable, so it's follow some logic to grow the size. Okay, grow the capacity. The main advantage of array list in Java, that if we declare the array, then we need to mention the size. Okay, and it is not needed to mention the size of array list, so it's not required in array list. So initial capacity of ArrayList will be 10. Okay, so it will be growable once your size will be completed. Your size will be your capacity will be full. Okay, so it will grow the capacity of your ArrayList with 50%. Okay, if you have if there is a size of your ArrayList is 10. Okay, so if it will be completed, if it will be full, then it will be enhanced by approximately 50%. That means the size will become 15. Okay, so internally it follows some algorithm to increase the capacity of your array list. Okay, so we are going to see hierarchy of collection. So iterable is a root interface, and collection interface implements iterable interface. Okay, and these three are the most important part of collections API, collections framework, which is list, queue, and set. We use set to store unique type of data. Queue we use to store this FIFO order. Okay, list we can store duplicate in list. Okay, so we are going to concentrate on list interface today. List array list. Okay, which is implementation of list. Okay, so in list, if you'll see the hierarchy of list, so array list implements list interface, linked list implements list interface, vector also implements list interface, stack also implements. Okay, So these are the hierarchy. Okay, but we are going to concentrate on array list in this tutorial. Okay, so we'll see one by one. So just now we seen iterable is a root interface collection implements this root interface. Okay, list is also interface which implements collection interface. Okay, and we are going to concentrate on array list. Okay, so array list implements list interface. Okay, these are the classes which is abstract collection and abstract list. Okay, so it's implements. So this is the abstract list. Okay, and this collection abstract collection. Okay, so array list extend abstract list as well as collection abstract collection. Okay, and array list also implements these interfaces, which is random access, clonable interface, and serializable interface. Okay, so this is the hierarchy of array list. So we are going to see some features of ArrayList. So ArrayList inherits abstract list class and implements the list interface. Just now we seen. Okay, so ArrayList is initialized by size. However, the size is increased automatically if the collection grow or shrink if the objects are removed from the collection. So it grows automatically. Okay, so Java ArrayList allows us to randomly access the list. A list can't be used to primitive type like int, char, etc. We need wrapper class for such cases. Okay, so we can use like integer, we can use boolean, okay, string. Okay, so all the wrapper class will be used in array list, but we can't use a primitive type like int, char. So array list is synchronized. It equivalent synchronized class in Java is vector. Okay, array list is non-synchronized. Okay, but vector is synchronized. So ArrayList got introduced in Java 1.2. Okay, and vector introduced in Java 1. Okay, so at the time of I think launching only they introduced the vector. ArrayList is a underlying data structure resizable array or growable array. Inside it use growable array, and array list duplicates are allowed. So it insert duplicate data in array list. It's possible to store. So insertion order is preserved. That means it follow the insertion order. Okay, in this scenario you are storing, it will be available in same scenario. Heterogeneous objects are allowed. That means the heterogeneous, that means that you can store multiple type of data. Okay, different type of data. That means that you can store string, int, okay, boolean. It is possible with the help of the object. You can create the array of object. Okay, in that scenario you can store the heterogeneous of data in array list. And null insertion is also possible, so you can store null value as much as you want. And constructors in array list. So we are going to see array list. So we are not providing, this will be the default constructor. Okay, so if you use this constructor is used to build a empty array list. If you wish to create an empty array list with the name array, then it can be created add. So like this we can create the array list. Okay, like this new array list, and array list equal to this will create the object of array list. Okay, we are not providing any argument here. So by default size will be 10, so it will create one array list with capacity 10. So this is another way to create the array list. This is another constructor. So here we have to provide the collection C. So this constructor is used to build an array list initialized with elements from the collection C. Suppose we wish to create an array which contains the elements present in collection C, then it can be created as like this. Okay, so on different collections you can also assign inside this array list. So like this you can create array list with argument. Okay, so third will be initial capacity. So you can also by default size in capacity will be 10. So if you want to create with 20 capacity, then we can use this constructor, and you can create array list with 20 and or 30 depend upon your requirement. So we are going to see all method which is available in array list. So we'll try to cover quickly, so we'll not take more time. Okay, add, so we use it to add. Okay, so we can do like add object. Okay, so we can add with index. Okay, insert a specified element at a specified position in the list. So here you can provide the index and element. Okay, add all, so it internally uses collections. Okay, we have add all with index and collections. Okay, we have clear remove all the elements from the list, clone it to it used to clone shadow. Okay, contains, if it is contained it will return true and false. Ensure capacity, so increase the capacity of the array list instance to ensure it can hold at least the number of elements specified. Okay, so basically we use it uh, in to increase the capacity of your array list. So by default size will be 10, but if you want to increase your capacity to 20, then you can use install capacity. Okay, so there you can make it 20, so your array list will be uh, your array list will contain minimum 20, size 20. After that it will increased by the algorithm. Okay, so get we use to fetch the data depend upon the index. Okay, index of, so we can, it will also return the true and false. Okay, so it will return the index of the object, so sorry, it will return the index of the object, like if it is not present then it will return -1. It's empty, if it is empty then it will return false, sorry, it will return true. Iterator, so we use iterator to iterate. So we'll see in coding part. So last index, so we can find out the last index of your object. List iterator, we use to iterate list. We have list iterator by index wise, we can iterate till index, we can remove with the help of the index. Okay, so if you are using 0, so it will remove the element of your 0th position. If you are using we have remove with object, that means that we can remove the direct, we can remove the data. Okay, with the help of the remove object. So here we are removing with the help of the index. Okay, so we have to provide 0 1 2 3. Okay, index wise here we can provide the data, like if you are storing, if you have a b c, then we have to provide the abc. Okay, so remove, it will remove your all collections. Okay, retain only the elements in the list that contains in the specified collection. So we'll see in coding. So we, so it returns only the common data. Okay, set to replace the data index wise, you can replace size to check the size of your array list. Sub list, so you can make a sub list from index to last index. Okay, we use to array to convert your array to array list to array. Okay, so in which type you want to convert, so you can use this to array. A team to size, so the team to size method in ArrayList class is used to reduce the capacity of ArrayList stand to be equal to the list current size. Okay, this is useful for minimizing memory uses when the ArrayList is not expected to grow any further. Okay, basically we used to save our memory. Okay, if you already added the element, okay, by default size of array list will be 10, capacity of will be 10. And if you have added the three elements, okay, so if you want to save your memory, then you can make it team to side, then your capacity will be 3. Okay, so here you can save your memory with the help of team to size. And list iterator, we used to iterate list. Okay, and remove, we can remove with index. Okay, so these are the methods we use in array list. Okay, to perform operations. So here we are going to do understand coding wise, so quickly we'll do, so will not take more time. Okay, so I did some R&D, so going to remove and again we'll do everything. So I have created here one class which is array demo and one main method. So I'm going to create list. So how can we create here? So list, just now we seen the constructor, with the help of the constructor we can create array list. So we have array list collection and with capacity, so we are going to use default array list. Okay, so we can initialize array list and list. Okay, so we are going to create array list string with a string type. Okay, so we can store heterogeneous data, similar type of data and different type of data, both we can store. So here we are going to store similar type of data, so we are going to array list. This is not required if we have already used type in type we have already used here. Okay, so I have created one array list. Okay, so I'm using here list interface, so it will be good to use interface name at the time of the creation of your object. So like this we can create the list. Okay, so by default size will be 10, capacity of array list will be 10. Okay, so we are going to add some data. Okay, some string quickly. So we are going to add abc. Okay, and then we'll see how can we add, delete, remove, all the operations. We'll see all the what we have seen in method description. Okay, okay, so we have added from a to e. Okay, so sys out, let's check if it is added or not. Array list, so I'm going to use control F11 to run this. Okay, quickly it will run. So A B C D E. Okay, so we have added the data inside array list. So we are using a string. We are adding a string type of data in array list. So here we have to provide type. Okay, it will be good to provide the type. Okay, because if you will not add this type, that means a string type, then it will give the error here. Okay, so it will be better to use type if you are adding a string type of data inside the array. Okay, so like this you can add. So we have some method, some overloaded method in add, so we can add with index. We have add all, so how can we do add by index? So we are going to do add by index. So now we have five data in array a b c d e. So we are going to we have a is available at first zeroth place. Okay, b is available at first place, and c is available at second place. Okay, and d is available as third place, and e is available at fourth place. So what we are going to do here, we are going to add here at zeroth position. We are going to add one element which is f. I'm going to add, so let's print and check. So yeah, if it added at zeroth position. Okay, with the help of the add with index. Okay, so a b c d, where if you want to insert at first position, then insert and let's check. Yeah, so see, this is the first position. So f is there at first position, and b c d e have shifted, okay, by one. So it's working good. So here what we can do, we have add all also and collections. So inside add all we have to pass the collection. So let's create one quickly. Let's create one array list quickly, and we will add by collection. So I'm going to do array list 2. Okay, so list 2 dot add. Here I'm going to provide z. Okay, so going to, so this is the second array list. Okay, so there I added one element which is z. Okay, so let's use this list dot add all. Okay, so here we will pass collection, and both collections will be merged here. Okay, so because we are going to add list 2 element, list 2 array list in list. Okay, so make it list list 2. So let's check what will be the output. So we are going to print a list. Okay, so running, I'm running. So a f b c d e z. Okay, so z is z, the element z is added in list, first list. Okay, a b c d e f. Okay, so we have added f at first position. So let's comment it, so it's not required now. So it will be easy to understand. A b c d e we have added in first array list, and z we have added in second array list. So if you are using add all, then it is merging your first array list to second array list. Okay, so we'll get output like a b c d e z. Okay, so we have added. So now we are going to remove. So how can we remove? Okay, like remove. Okay, so we have list dot how we have overloaded method to remove. We'll see one by one. We have index object collections. Okay, predicate. So we are going to remove by index. So we have used zeroth element, so it should remove a. Okay, we should get b c d e. I'm printing list, so I'm going to comment this list dot add. Now not required, we have understood. Okay, so I'm going to list dot we have removed a zeroth position. Okay, so let's see what will be the output. So output should be b c d e. Okay, so let's run. So we are getting b c d e. So we have removed by index. So we have also list by list dot remove. So remove by object. So let's remove by object. So we are going to remove here d. Okay, so we are going to remove by object. So let's run and check. So we are getting here bce. Okay, so d has been also removed from this list. Okay, so we are getting bce because we have removed the zeroth element, okay, which is a, and we have removed the d. So we are getting bce here in output. Okay, so we have also option to, some overloaded method to remove, which is remove all. So let's remove all. Okay, so we are going to remove list first. Okay, so let's remove and check list dot remove all. So what will be the output? We'll learn and we'll check. So output will be blank because we have removed everything. And we have list dot remove with predicate. Okay, remove if available, then remove. So we are going to comment this and this. We have understood everything. So predicate, that means the we have to provide it takes input and it's return boolean value. So we are going to x dot equals. Okay, let's provide a. Okay, let's check what will be the output. So we are going to print b c d e. Okay, so if x equals a, okay, that means the if a is already available, then remove it. Okay, so it's removing a, we are getting a b c d e. So like this we can remove. We have overloaded method to remove. So let's do some iteration. So how can we iterate? Okay, so we have list dot iterator. Okay, this is the iterator method which is available inside list. Okay, so with the help of the iterator we can also iterate, and with the help of enhance for loop also we can iterate. With the help of the for each method we can also iterate. So we are going to check with the help of the iterator. Okay, so here will be the list iterator. Okay, of a string and iterator. Okay, so while we are going to take, we'll do here iterator dot has next. Okay, and then we'll print here iterator sys out iterator dot next. Okay, so like this we can iterate. So I'm going to comment this remove part. Okay, so we are going to iterate. So I'm going to comment this also. So let's iterate and check it's, are we able to iterate with the help of iterator? Yeah, a b c d e, yeah, we are able to iterate. We are, it's working. So we have another way to iterate, which is for each. So let's check quickly. List dot we have for each method. Okay, so it's the consumer. So we are going to, so like this we can also iterate sys out system dot out dot print ln system. Okay, here we can here can we use method reference, okay, to print, like print ln is a method, print ln, print ln is a method inside system ln. Yeah, so let's run and check are we able to iterate or not. So we are going to comment iterator code. Okay, we'll check with, now we are going to check with for each it's working or not. So I'm running, okay, a b c d e. Okay, so we are able to iterate with the help of the for each method also. And we have list dot stream, parallel stream. Okay, so we will use parallel stream also to iterate here. So parallel stream, we have a stream and parallel stream both. Okay, so firstly we'll try to do with stream. So here also we can, for each method is also available in stream, so you can use a stream here to iterate. Okay, stream. Okay, so there is a method inside, uh, there is a method stream inside list, so we can also use a stream because for each method is available in both, in stream and list, so we can use for each method to iterate. So we'll see here difference between list and we have parallel stream. Okay, so we can also use parallel stream to iterate here. Okay, so we same we can do in parallel stream. So I will show what will be the difference between stream and parallel stream. So internally parallel stream takes uh, multiple threads to execute this operation. Okay, so it will be executed by one thread, it will be executed by one thread. Okay, sequentially th thread, and it will be by multiple thread. So this is also important question, difference between stream and parallel stream. Okay, so let's do it by parallel stream. So going to iterate by parallel stream. So c d e a b, so we are getting c e d a b. Okay, so we are able to iterate. So it's doing with the help of the multiple thread. Okay, and let's print with the help of for each. So we are getting abcd. Why we are getting serialized manner in first, and we are not getting in second? Because yeah, it's using one thread, so it's doing serially one by one. Okay, and in case of second one which is parallel stream, so it's using multiple threads to print. So we are getting cedba. So the printing manner is not sequentially in this case, because it's internally using the multiple thread to execute parallelly. Okay, so like this we can iterate in array list. Okay, and we have also some methods. We'll try to understand list dot clear. We can clear all the list. Okay, without clear we have contents. Okay, so let's check contents, that means it's available or not. The list dot contents a, will check a is available or not. So let's print this out. So I'm going to print it's available or not. So it will print the type of content is boolean here, getting here boolean. Okay, so it will return boolean if it is present, if it is not present it will return true and false, it will return. So let's run. So I'm getting true because a is present. So in our list we'll check if is not present, so we'll do here if, and we'll check if is not present. Yeah, here if is not present, so we are getting false here. Okay, so this is the contents method we have seen, and we'll check on any other method is remaining. We have get method. We can use get method to fetch the value with the help of the index we can fetch. So here I'm going to first we are going to provide. Okay, so let's print inside sys out. Sys out. Okay, let's copy and put inside. So let's print get. Okay, so we are getting b. Okay, so b is available at first position. This is our first position, so we are getting b. Okay, so get is also working good. So we can also print the size. Okay, so how can we print the size? So we have size method, list dot size method. Okay, so we can print the size. So let's print size. So what will be the size? So size will be 5 because we have a b c d e. Okay, so e. Okay, so we have 5 elements in first array. Okay, which is list. And let's check if any other method is remaining. We'll check one by one. For each we have seen get has got index of. Okay, so index of. So we did not see index of. Say here it will take object and it will print the index of that object. So we are going to print index of a b c. So we'll do here sys out. So what will be the index of a? Will print and we'll see. I'm going to comment previous method, previous things which we have discussed. Okay, so what will be the index of a? Zeroth. Okay, a is available at zeroth position, so we are getting a. What will be the position of b? So let's run. So we are getting b 1 because b is available at first position. Okay, so like this we can print the index of your element which is available in array list. So list dot, we'll see any other method. Iterator we have seen last index. Okay, list iterator we can also use same as iterator to iterate the list related things. Okay, notify all, you know. Remove we have seen, replace all. Okay, set we can, with the help of set we can replace. We have sort method also. With the help of sort we can sort your array list. So we'll see set and then sort. We'll see. So we have set method, so we can replace like zeroth position we can replace with any element, like we are going to do like y. Okay, so here, and I'm going to print list. I'm going to print list here. Okay, see now we are getting y b c d e. Okay, so now a has been replaced by y. Okay, so at zeroth position what was our value? Our value was 1, a. So now a is not there. In the sheet of a we are getting here y, so we are getting y b c d e. Okay, so like this set we can remove. So now we have sort method also inside list. Okay, so we have a sort method, so we use sort to sort the element which is available. So it will take comparator, so we'll do comparator. We have method in comparator, we have method comparator dot comparing. Okay, so we'll do so by which we want to x. So we want to sort by string which is available. So now we'll get a b c d e. We are getting in sorted order a b c d e, and but previously we were not getting in sorting order. Let's print again what was previous order. So a b c d e, a b c d e. Okay, so I think it has been a b c d e. Okay, because everything is, so here we'll make it uh, c and here we'll make it a. Okay, so c b a d e we should get at first time. So c b a d e are we getting. Okay, but after sorting we are getting here. Okay, here we are getting unsorted and here we are getting sorted. Okay, so like this we can do. Okay, and we can do with the help of steam API. We can also do list dot steam. Okay, so in steam also there is sort method, so there we can also do. So and with that list we can also sort. These are the methods. So let's check any other method. List dot get index, notify parallel, retain all, splitter. Wait. Okay, we'll see retain all. All is also a method. Okay, so it will provide the common list. And here we are going to list dot return all, and list 2 we are going to do it will return true. Okay, if it will, and it will provide the common object which is available in both the list. Okay, so I'm here going to comment the previous things to avoid the confusion. Okay, so what we are going to do here, list dot return all list 2. So we have list and list 2. So in list 2 we have z, and in list 1, in list we have a b c d e. Okay, so we are going to put a in list 2, and let's check what it is happening. List dot return all. Okay, and list 2. So let's run. So we are getting here, you're not getting anything. Why? List, let me print, then we'll get sys out, sys out, sorry. Yeah, so now we are getting a, so we are getting a common value which is available in both. Okay, here a is available in both. Okay, so we are getting a, we are not getting c d, c b a d e. Okay, what it is happening actually inside, I will explain. So list dot return all, so it's removing all the elements which is which is not available in list 2. Okay, so your c b d e will be removed from list a list, and only a will be available. Okay, so when we are printing the list, then we are getting only a here, list dot return all, and we are printing here list, then we are getting a only. Okay, so let's provide some uncommon value in list 2. So here I'm going to provide z. Okay, so z is not available in first list, and z is available in second list. So let's print, because there is no any common value, so it should not print anything, it should print blank. Okay, so let's check. So I'm going to print directly with the control F11. So we are getting it blank. Okay, so our list is, and list dot return will return true and false, because it has your data has been changed. Okay, okay, list has been changed. So return type will of return or will be the boolean here. Okay, so like this we can perform all the operations, all the method which is available in ArrayList. Okay, I think you understood everything, because we have started from core to advanced. Okay, we seen all the constructor which is available in ArrayList, all the method. Okay, we did the coding, collections framework. So we are going to cover linked list today. In this series, we'll cover all this topic, which is what is linked list. We are going to cover first, then linked list in hierarchy of collections. We are going to cover, then how does linked list work internally. We'll see, then constructors in linked list, all the constructors we will see which is present in linked list. Then key point of using linked list in Java. Okay, why we use linked list, so we'll see. And then advantages of using linked list, then disadvantages of using linked list we'll cover. Then methods which is present in linked list, all method we will see. And difference between list and linked list. Okay, which is very important questions according to interview, difference between list and linked list. And at last we will see coding questions of linked list. So we'll add linked list, we'll do some operations, almost we'll see all the necessary methods in coding question. So we are going to cover all these questions in this series. Okay, so let's get started. So we are going to see what is linked list. So linked list is a part of Java collections. This is linked list is a part of Java collections framework, and implements both list and DQ interfaces. Okay, so it implements list and DQ interfaces, allowing it to function as a doubly linked list. Internally, it uses doubly linked list concept to perform linked list operations. Okay, it differs from linked list in how it stores elements, offering more efficient insertion and deletion, but slower access when using indexes. So it is more efficient in deletion and insertion, because order time complexity will be very less than array list. So if you are doing any insertion and deletion, to better to use linked list rather than array list. So time complexity will be order of 1 in case of linked list for deletion and insertion. So second, linked list is a part of collection framework present in java.util package. So this class linked list will be present in java.util package. Okay, and this class is an implementation of linked list data structure. So this class is internal, this class is internally linked list data structure. Okay, it use w linked list just now we seen here. Which is linear data structure. So linked list data structure is a linear data structure where the element are not stored in contiguous location, and every element is separate object with a data part and address part. The elements are linked using pointer and addresses. Each element is known as a node. So I will try to describe shortly. It will not more time to understand w linked list. So linked list internally use w linked list concept. So how it works I will tell you. Give me 1 minute. Okay, so it store data as a node. Okay, so let's imagine we have linked list. Okay, so we are going to store four four element. Okay, in linked list. So how it will store? So it will store as, okay, we are going to store four linked list. Okay, so so our linked list will be visible like this. Okay, at the time of storing. So we are going to store 10 here. Okay, then we are going to store 20 here. Okay, and then we will store 30. So we are going to use here w linked list. Okay, so here 30 will be there, data will be available here 30. Okay, so what is happening here? So in w linked list, the first, here it will store the address of previous node, and here it will store the address of next node. Okay, this is one node. Okay, so let's imagine the address of first node will be xx10. Okay, and address of second node will be xx20. Okay, so xx10. Okay, so this is the address of first node, and address of second node will be xx20. Okay, so this 20 will be stored at address xx20, and 30 will be stored at address xx30. Okay, let's imagine, and then we'll try to understand how w linked list work internally. Okay, it will not take more time to understand because this is the basic concept. If you not understand, it will it might take time to understand. So this is the basic. So here there is no previous node in case of w linked list. So here what will be the value of previous? It will be null. Okay, so there is no any previous node because this is the first element 10. So here it null will be stored, and this is the this here it will store the address of next node, which is xx20. So it will store here xx20. Okay, xx and 20, and in second node what will happen here? So data which is available at second node, okay, is 20. So here it will store the address of previous node, which is xx10. So it will store here xx10, xx, and then 1, then 0. Okay, so and here it will store address of next node, which is 30. Okay, the data we have stored here, which is 30, but address of this node is xx40. So here it will store xx40, xx and 40. So this is the address of second node, address of the next node. So here it will store address of next node, and here address of previous node, address of next node, and then address of previous node. So here only we are going to store three objects. Okay, three data. So we are not going to take fourth one. Say at the time of third, what it will do? So here it will store again address of first previous node, which is xx20. So the xx20 will be stored here. Xx20 is address of previous node, xx20. Okay, but what will be what we can store here? Okay, because there is no next node. Okay, there is no next node, so this is our last node. So here it will be again stored null. Okay, because there is no next node after this node, so null will be stored here. So xx10, xx20, and xx30. Okay, we have stored 10, 20, 30. Okay, so here data will be stored, which is 10, 20, and 30. Okay, and here at the first previous node address will be stored, and here next node address will be stored. Okay, so like this w linked list work. Okay, so linked list internally use w linked list to store all the data. Okay, all the objects. I hope you understood this basic concept of linked list. So we are going to move forward to understand new topic, which is hierarchy of collection. So we are going to see how linked list work in collections framework. Okay, so this is the complete picture of collections framework. So this is a root interface which is iterable, and then collection interface. So collection interface implements a collection is also interface. So collection interface extend iterable interface. Okay, and then list is interface. So list interface also extend collection. Queue also extend collection interface, and set also extend collection interface. So but and list, these all are the implementation of list. Okay, array list, linked list, vector, and stack. But we are going to concentrate on array list. No array list, we are going to concentrate on linked list. Okay, so this is the linked list. So the linked list is a direct implementation of list interface. So linked list implements list interface. Okay, and there is second things, which is dq. So dq is a class. So sorry, dq is an interface. Okay, which extend q list. Okay, so q is also a list, and dq is also a list. So dq extend q list. Okay, and linked list extend dq. So so we can say linked list class implements a list interface and implements dq interface. Okay, so both the so we'll get both the method. We will get the both the method in linked list. So some of the method will be from list interface. Okay, and some of the method from dq interface. So it's act like both, like dq and list. Okay, so it's a mixture of list and dq. So we are going to understood linked list. So I shown you the complete picture of the collection. uh, so it will be easy to understand. We are going to cover next topic, which is how does linked list internally works. Okay, so since a linked list act as a dynamic array, and we do not have a specify the size while creating it, the size of list automatically increase when we dynamically add and remove item. So there is no any size. So once it will be once the size will be completed, okay, full, then it will be increased dynamically. The linked list is implemented using a double linked list data structure. So just now we seen, okay, in previous slide. So the main difference between the normal linked list and double linked list is that a double linked list contains an extra pointer. Okay, so just now we seen there is two type of linked list, which is first will be the single linked list, and second will be the double linked list. So in single linked list it will only one address will be there. Okay, so that address pointer will store the next address of your next node. Okay, but in case of a double linked list, just uh, just now we seen the double linked list. So it has two place to store the address pointer. Okay, So in first it will store the address of previous node, and second it will store the address of next node. So this is the difference between the single linked list and double linked list. Single linked list and double linked list. Constructors in array list. Okay, so how can we create the linked list? Sorry, constructors in linked list. So how can we create the object of linked list? So we can create with the help of the constructors. So we can create like this. Any, no need to pass any parameter here. Okay, this constructor is used to create an empty linked list. If you wish to create an empty linked list with name ll, then it can be created at. So this will be the reference variable name ll. Okay, linked list. So like this we can create. And there is another option by we can pass the collection inside the as a parameter in linked list constructor. Like this new linked list that I'm creating, this is the this collection may array list. Okay, or any other collection you can pass here. So both the way we can create linked list object. And key point of using linked list in Java. So why we use linked list in Java? So linked list is implemented as a doubly linked list. Each element, that means node, contains a reference to the previous and next element in the list. Okay, so just now I shown you in previous slide I shown you. So in linked list, in doubly linked list, we can store address of reference of the previous node and reference of the next element. Okay, and allowing for bidirectional traversal. So, uh, so this is the advantage of linked list. So it will be better to use linked list, and time complexity will be very less because it's pointing to both direction, previous and next. Efficient insertion and deletion. Unlike linked list, efficient for insertion and deletion. Unlike array list and linked list is more efficient for inserting and removing inserting and removing elements in middle at both end. Okay, order of one for these operations, as no element need to be shifted. However, random access getting elements by index is slower order of n compared to array list. So you know, if you want to insert or delete from middle of collection, so it will be better to use linked list. Okay, because time complexity will be order of one. Okay, so if you want to remove, so what you have to do, I will show you quickly. I think in previous slide we have covered this. Okay, so if you want to remove this 20, so it will not take more time to remove. Why it will not take more time to? So because in next here, okay, at the first node, what we can do in next. Okay, in next address we can pass xx40. Okay, instead of passing xx20 we can pass xx40 here. Okay, so it will not take more time. Okay, so time complexity will be order of 1 in case of insertion or deletion. Okay, so this is the advantage of linked list. Okay, so time complexity will be order of 1 for insertion or deletion in middle of your linked list. So let's go again to our topic. And next, efficient insertion deletion, just now we seen. Okay, implements list and dequeue. So linked list implements both the interface, which is list and dequeue interface. As a list, linked list can store element in sequence and allow positive positional access, and as a dequeue in support operation at both the beginning and the end of the list, functioning like a dequeue, functioning like a queue or a stack. Okay, so it works like list and dequeue null element. So linked list allows storing null element. So we can store null element in linked list, same as array list. So it is also non-synchronized. Okay, this is similar to array list functionality. This is linked list is not synchronized, meaning it is not thread safe. External synchronization is required when used in concurrent environment. Okay, because it is not synchronized, so it is not thread safe in multi-threaded environment. An advantage of using linked list, so dynamic size, as with vector, the size of linked list can grow or shrink dynamically. So we don't have to worry about setting an initial size, so it will grow dynamically. Okay, like vector. Efficient insertion and deletion, just now we seen this is advantage of insertion and deletion. If you want to insert or delete from middle of your collection, then it will be better to use linked list. So flexible iteration, with a linked list you can efficiently iterate through the list in each direction, since each elements has reference to both it. Okay, actually it is easy to iterate also, because it is pointing, it points both the direction, that is left and right, previous node and next node. Disadvantage of using linked list, performance wise, so linked list has a slower performance than array list when it comes to accessing individual elements. Okay, this is because you need to transverse the list to each the desired element, whereas with array list you can simply access the desired element using an index. Memory overhead, linked list requires more memory than array list, because each element requires additional memory for the links to its predecessor and successor. Now we are going to see all the method which is available in linked list. Okay, some of linked list implement list interface. Okay, linked list implements list interface. So some of the method will be from list interface. Okay, and some of the method will be from interface. So I will show you the code of the linked list, so that it will be easy to understand. So which method is from queue and which method is from list. So this is a linked list. Okay, I'm going to show you internal of linked list. So this is a linked list class. So linked list extend a stack sequential list and implements list and dequeue. Okay, so if you see the list, so some of the methods are present in list, which is size, is empty. Okay, contains, iterator, to array, add all. Okay, remove all, sort, equals, hash code. Okay, add, remove. Okay, index of object, last index of. Okay, list, iterate, sublist, splittator. Okay, all these methods we have already covered in ArrayList video series. Okay, so you can also go and you can also check that playlist. So these are the methods available in list. Okay, and if you check the DQ, so DQ extend queue interface. So some of the method are from DQ. Okay, like offer first, offer last, remove first, remove last, poll first, poll last, get first, get last, pick first, pick last, remove last occurrence. Okay, add, offer, remove, poll. These all are methods from queue. Okay, push, pop, queue interface. Okay, if you see, and queue extend, DQ extend queue interface. So some of the method will also from queue, like remove, poll, element, pick. Okay, so these are methods from queue. These methods belongs to queue interface. So this is the internal of linked list. So linked list extends abstract sequential list. Some of the methods are from abstract sequential list, like get, set. Okay, these are the methods remove by index. add all, iterator, list iterator. Okay, so these are the methods which is present in abstract sequential list class. Okay, which is extended by linked list. So we seen all the class and interface which is available inside linked list. Okay, so we are going to see method, and we'll try to understand the purpose of this method. Okay, add, we use it to add the element. Okay, so the method insert the specified element at the specified position in this list. So add is there, and add by, you can here add object, add all by index. Here we have to add the index and the collection. Okay, and add all, so we can add the collections. Add first, so element will be stored at first place. At last, the element will be stored at last. Clear, it will clear all the array list, sorry, link list. Or it will be removed. And clone, you will get the one copy of linked list. And contains, if contains, then it you will get true and false. And descending iterator, this method returns an iterator over the element in this DQ in reverse sequential order. An element, this method is retrieve but does not remove, okay, the head of this list. So it will get it will fetch the first element, but it will not remove. Get by index we can fetch. Okay, and get first, you will get the first element, and get last, you will get the last element. And index of, so you will get the index of your object. If it is not present, you will get the -1 last index. Okay, so last index of your object. And list iterator, this method returns a list iterator of the element in this list starting at the specified position in this list and offer. So this method adds the specified element as the tail. Okay, last element it will add. Offer first, so it will add at the front of the list. Offer last, that means that it will add at the last of the list. So we have offer, first, and last. So first will add at the first, and last will be at the last. And pick, so this method retrieve but does not remove. So first element it will retrieve but it will not remove. And pick first, this method retrieve but does not remove, and the first element of this list, or return null if there is no any value. If and pick last, so it will return the last. If a value is not there, then it will return null. And poll, this method retrieve and remove the removes the head first element of this list. So it will remove the first element and also return. This method retrieve and removes the head, which is first element of this list. And poll first, this method receive and removes the first element of this list or returns null if this list is empty in case of poll first. So these all methods are from DQ. Okay, DQ interface. Poll last is also there. Okay, pop and push. This is okay. So this method pop an element from the stack represented by this list. Okay, so it one uh, pop, that means the it will delete, and push, that means the it will push, it will add, remove. So it will remove. Okay, so this method retrieve the and remove the head first element of the list. Remove by index, so you can index wise you can remove by object, you can object wise you can remove first, it will remove the first element. And remove first occurrence, so this method removes the first occurrence of the specified elements in this list. Okay, when traversing the list from head to tail. Okay, remove last, so it will remove the last of the element. Okay, remove last occurrence, so this method removes the last occurrence of the specified elements in this list. So it will be stored remove the last element. And set, so here you can set the set the index wise you can set object, okay, at the index. So this method replaces the element at the specified position in this list of the specified element, so it will replace. Okay, so that means it will replace. And size, so to get the size of linked list and splitter, this method create a late binding and fail fast splitter over the element in this list. So to array, this method returns an array containing all the elements in this list in proper sequences. So I try to explain all these method between 2 to 3 minutes. Okay, and you see the coding questions of all the method, all the important coding method, all the coding questions of all the important method. Okay, and you can play with all the methods so that it will be easy to analyze, it will be easy to understand. So now we are going to cover array list and linked list. So we are going to cover difference between array list and linked list. So it is it is very important question according to interview. So implementation wise, we'll see. So array list implement resizable array. Okay, you can say growable array, resizable array, and linked list implementation of linked list is doubly linked list. Okay, package, both are available in same package. Memory allocation stores elements in a dynamic array where contiguous memory is used, and store elements as node where each node holds a reference to the previous and next node. Access time, order of 1 for fast random access and slower random access, order of n. Okay, insertion time. Okay, at end, if you want to insert with the help of array list, so it will take order of 1. Okay, and for insertion list, if you want to insert at end, then same order of 1 will be for in linked list. So in at the time of insertion at last, so order of time complexity will be same for both scenarios, for at least and linked list. Insertion time in middle, if you want to insert something in middle, so linked list is faster because time complexity will be order of 1 in case of linked list, and in case of array list, if you want to insert something in middle, so order of time time complexity will be order of 1, because if you are going to insert all the index, you have to shift. So this is the issue in array list. So better to use linked list if you are doing anything, that means insertion and deletion in middle. So deletion at end, so deleting anything from end, so you can use anything like linked list and array list, you can use both. Okay, because in both the scenario, time complexity will be order of 1. Deletion at middle, so it is faster in case of linked list. Okay, if you are deleting anything in middle, so it will be slower in case of array list, because array list internally use dynamic array concept. Okay, so if you are deleting anything, then again you have to shift your all the elements, you have to shift. Iteration time, faster iteration due to contiguous memory access. Okay, and slightly slower due to pointer hopping between nodes. Memory overhead, less overload, stores only data in an array. Okay, and more overhead due to storing pointer along with data. Use case for adding, removing. Best for frequent retrieval and infrequent insertion removal, especially at the end. So best for frequent retrieval if you want to retrieve. Okay, so in that scenario you can use array list. And best of infrequent insertion removal at the both beginning and middle. Okay, so in case of beginning and middle, if you want to insert and delete, then in that scenario you can use linked list. Initial capacity will be 10 for the array list, and there is no fixed size for initial. There is no fixed size for linked list, and for array list there is fixed size. The default size will be 10, and resize behavior automatically size by creating a new array and copying element costly for large list. Okay, No resizing required. Memory efficiency, generally more memory efficient, less memory efficient due to extra pointer. Okay, so here you have to memory wise it's not good, but performance wise very good. Linked list is very good if you are doing insertion and deletion, okay, in between your collections. Indexing, okay, supports efficient indexing order of 1, okay, inefficient indexing order of n. Thread safety, okay, so both are not thread safe, okay, because all are not both are not non synchronized. So in case of array list we can store null value, and in linked list also we can store null value. Transversal method supports both iterator and list iterator, and supports both iterator and list iterator. Okay, so it supports list and iterator. List iterator and iterator and list iterator for the both the scenario. That means for both the collection array list or linked list. So we have covered all the features of array list and linked list. Okay, some of the similar and some of the we have differentiated array list and linked list. So now we are going to see the coding questions of this array list. So I have covered the all start. So I have created one linked list. Okay, so linked linked list. Okay, equal to new linked list. So here I'm adding. Okay, list dot add list dot add. So apple will be added here. Okay, so we have another method which is add first. Okay, so mango will be at first position and then apple. Okay, and at last. So now we have apple, first we have mango, then apple, and then last will be orange. Okay, so our scenario will be mango, then apple, and then orange, and then add at first index. So what is there at first index? Okay, so that will be delegate to second index. Okay, and now for, at first, what will be at first index? Banana will be at first index. So what will be our scenario if you will check? Okay, so at first what will be, mango will be there, and then banana will be there because we are adding at index first. Okay, and then we have apple, and then we have at last we will be have orange. Okay, so this will be the output. Let's run and check are we getting correct output or not. See, we are getting mango, banana, then apple, then orange. Okay, let me run one by one because you will be confused. Okay, so we have added list dot add. Okay, let me run list dot add. So here we are getting apple. So now we are doing list dot add first. Okay, so mango will be at first position and apple will be at second position. So I'm running again. So now we are getting mango and apple because we are adding with the help of list dot add first. Add first is a method. So we are getting mango and apple, and at last after that we have list dot add last. Okay, that means the orange will be added at last. So let me run and check are we getting mango, apple, and then orange. Mango, apple, and orange we are getting. Okay, so now we are going to add banana at first position. First position, that means the here. So now at first position apple is the apple is available. Okay, so now apple will be at apple, banana will be available, and then apple will be available at next position, and after that orange will be available. So we are going to add banana at first position. So let me check output. Mango, banana, apple, and orange should be there. Mango, banana, apple, and orange. So we are getting the correct output. Okay, that means we are now I'm going to access access elements. Okay, so how can we access? With the help of the get method. So we have get first, get last, and get. Okay, same like add first, add last, and add. Okay, we have get first, get last, and get. So get first will get the first element, get last we will get the last element, and second we are fetching a second element, so we are providing here index of second. Okay, so index of second, so here we are providing first. Okay, because for fetching we provide 0, and for fetching second we provide 1. So let me run and check. So we have to uncomment this, then it will, then we'll be able to see. Yeah, we are getting first mango. Okay, which is right. Second banana we are getting right, and last we are getting orange. Okay, which is right. And now we are going to remove. Okay, so we are going to use remove method and remove last. So with the remove method, remove the first element, and we remove last, remove the last element, and we'll print. Let me run and check, are we able to remove correctly or not. So we have removed the, with the remove method we have removed the first. So we have removed the mango, so now we are not getting mango, we are getting banana, apple. And remove last, so it's remove the orange, so we are getting, we are not getting orange in this list. Okay, linked list, we are getting banana and apple, so we are getting the correct output. Now we are going to search the element. So how can we search? So we can search with the help of these methods. Okay, so list contains, so it will return true if banana is available. List dot index of apple, so it will return index of apple which is first. Okay, and list last index of apple, it will return, so which is 1. Okay, apple is at one time, so let me run and we'll check the output. What is the output? Yeah, so banana contains banana, true. Okay, list contains banana, but we have list banana, we have in list we have banana and apple. So contains banana, has banana, so list dot contains banana, yes, so we are returning true. And first apple, okay, index of first apple, so we are getting 1. Okay, so apple is present as first position, first position is index first, so we are getting 1. Okay, so index of banana will be 0 and index of apple will be 1, so we are getting here 1. And last index of apple, we are getting last index of apple. What we are getting, because only one apple is there, so we are getting same for first and same for last. So now we are going to size. How can we check the size? With the help of size method we can get the size of linked list. So let me run this again, we'll get the size at last. So we now we have two fruits in linked list, so we are getting size of list is 2. Okay, so at last we have poll method. So what we can do with the help of poll, so retrieve and remove the first element with the help of the poll. Okay, so let me uncomment. So retrieve and remove the first, so we are going to use list dot poll. So first, in first one we will get, what we will get in first one, first banana is there, so in first we'll get the banana. And list, after removing the first element which is banana, we'll get the list. So in list we should get only apple. So let me run and check. We are removing banana, will get only apple. So we have removed polled, that means we have removed banana, and after removing banana we are getting only apple. So we can remove with the polled method, can remove first one. And we have pick method. Okay, so with the help of the pick method we retrieve but do not remove. Okay, so we'll fetch the value. Okay, but will not remove. let me run and check. So I think we have only one. So it's able to fetch, okay, apple. Let me add here, okay, list dot add. We are going to add here what we are going to add, orange, okay, then run. See what we are doing here. So we have apple, okay, we have added orange, so now we have apple and orange both, okay. So we are doing list dot pick. So we are able to pick first, which is apple, okay, but we are it's not deleting the element, we are only able to fetch the element. So we are able to get apple, but okay, let me run here, let me print all the list after adding, okay, so that we'll get both. We have added new element, which is orange. So now we are getting here list after pool. No need to list after pool, no, normally print, or I will confuse. List after added orange, okay. So we are getting list after added, list after adding orange. We are getting apple and orange, okay. So when we are doing list dot pick, so we are able to fetch first element of this list. So we are getting apple, okay, and we are getting all the fruits name in list, okay, because it is not deleting. So it will pick will only fetch, it will not delete first element. So now we are going to clear all the element which is available in linked list. So now we have two element in list, okay. So after clearing, it should get empty. Let me run and check. Yeah, we are getting the empty list, okay. So we are getting the correct output. Let me comment, and now we'll do remove, okay, because nothing will be there. If nothing will be there in list and we'll try to remove, we'll get the exception, okay. So now we are trying to remove, which is list dot remove first and list dot remove last, okay. So with the help of this we can remove. Let me uncomment it. And if you use remove, then first element will be removed, okay. What is happening? Remove last first and remove last, then what should we get? We should get null, because nothing will be available in list. So let me uncomment this, okay, so that we'll get. Let me run again. Yeah, we are getting dequeue after removal, okay. So this is the method from dequeue. So we are printing dequeue after removal. So we are able to remove with the help of the list dot remove first and remove dot last. So I have, yeah. So if you are loving my effort, please like, share.